from 1 to 100. Okay, and that's the example that they show on page 91 and 92. Okay, so what you need to do is, first of all, cross out 1, because 1 is neither prime nor composite. Okay, first thing you do, circle 2. Now, you can either cross them out. So, 2 goes into what type of numbers? All the even. Okay? So, however you want to do it, well, you can do this. And cross them all out. Okay? So, we start with 6, 8, and 10. That all goes out. Okay, so when you're done with that, so what are you left with? Odd numbers. Except for 2. That's why it's the best number. Not 73. 2. Okay? So now you're left with just odd numbers. So now the trick is, okay, so you circle 3. And then you cross out all the numbers that go into 3. And if they're already crossed out, don't cross them out again. So like 6 is already crossed out. You don't have to cross that out. So if you go to the single digits, the first one is 9. You cross out 9. So let's go to this column here. How about 21, 51, and 81? Okay? You go to column 2, well, they're all done. Column 3, first one is 33, then 63, 93. If we go with 5, we know it's 15, 45, 75. Okay? If we go to 7, 27, 57, 87. And then the 9 column, what is that? 39, 69, 99. Now, what was the trick about 3? Well, you count every 3, but look at the numbers. 2 plus 1 is 3. 3 goes into that. 3 plus 3 is 6. 3 goes into 6. So when you add the 2 up, that's how you get rid of them. The next one, circle 5. Now, 5 goes into what numbers? Right, and the zeros are already crossed out, right? So what's left is 25, 35, 55, 65, 75 is done. There it is. So now you're narrowing the primes down even farther. And there's one more. 7. And then we're done. I believe there's 3 numbers left that you have to find. Anybody know what they are? James?
77.
77 is one of them. Good. So we can eliminate 77. 49. Good. And there's one more.
43.
No. 91. 91. The single digits, you have 2 and 5. Okay, are prime. But look at all the double digit numbers. What do they end in? Well, I see a 1, 3, 7, or 9. So prime numbers besides 2 and 5 end in 1, 3, 7, and 9. Those are the ones you have to know. So now on the Goldberg conjecture, which I probably could have done, now you could look at those and say, okay, if I wanted 100, okay, I see 97 or whatever, 3, I could have done that, and that worked. That's open, I'm good. That's all you have to do on those. So those are the prime numbers from 1 to 100 for those. Any questions on those? 1 to 100.
Does that only work for double digit numbers?
What's this?
So 1, 3, 7, or 9? Is that, you can use it for like the thousands?
You can, but it gets a little bit more complicated. Well, you know, any even number is going to be not going to be there.
Right.
So if there's a good chance if the 3-digit number ends in a 1, 3, 7, or 9, there's probably a good chance it's going to be prime. Not necessarily, but again, how you can tell that is, well, add them all up and see what you get. You know, because if you know 1 in the number, but if any other number besides 1 goes into it, then you know it's going to work. Like 111. 1 plus 1 plus 1 is 3. 3 goes into 3, so therefore 111, even though it ends in 1, is really a composite number because you have more than 2 factors.